Right, now dinner and Max has been dispatched from The Apprentice. Let's have a look at this. So, right, so we've got our parallelogram, our vectors. We are told that the ratio of lambda to mu is 1 to 2. So first of all, that means that mu is equal to 2 lambda, right? Because if you imagine if this is split into 3 sections, this is our lambda and 2 parts is mu. So this mu covers 2 parts, so that means that must be 2 lambda. Okay, right, so now we've got a ratio for that. So now we're going to use our diagram to show what mu is worth. Okay, so what we're going to do is we are going to try and replace one with the other. So what I'm going to do, I know that KLM is a straight line. So I'm going to find vector KL. Right, now this whole A to B is A, and A to B is split into A to K, K to B. So this part at the bottom is equal to mu A, and this part at the top is 1 minus mu A. And the same thing on the other side. This is C to L is mu, so this is minus mu A, and then down here is 1 minus mu A. Actually, let's make this consistent, right? So we've got 1 minus mu A and mu A, okay, because now they're all going in the same direction. Okay, so what I'm going to do, I'm going to switch this mu A, because mu is equal to 2 lambda, so I'm going to call it 2 lambda A. Right, so for KL, I'm going to go from K to B, then I'm going to go from B to C, and then I'm going to go from C to L. So K to B, that is 1 minus lambda times A plus BC, that's B. And then I'm going to take away, because I'm going in the opposite direction, 2 lambda A. And then I collect my like terms. So I've got 1 minus lambda, another minus 2 lambda. So I've got 1 minus 3 lambda times A plus B. Okay, now we said KL and M are all on one straight line, so that's KL. So now I'm going to do KM. So KM, I'm going to go the other way. So I'm going to go from K to A. I'm going to go from A to D. And then I'm going to go from D to M. Okay, so K to A is minus lambda A. A to D is parallel to B, parallel to BC, so that's B. And then D to M, we are told that D to M is half a B. So we'll add a half B. And again, let's collect the terms. Minus lambda A plus B, plus B plus a half, so altogether that's 1.5 or 3 over 2B. Okay. So now I've got to try and work out the fraction of the KL is a KM, because KL is equal to something times KM. Right, so let's compare the A's. So for KM, the KL, I've got 1. Let's do the B's. The B's are really easy. Okay, so I've got 1B, and for KM, I've got X times 3 over 2B. So now what I've got to work out is what is that x? So if b is equal to 1.5 x times b, that means that 1 is equal to 3 over 2x, and therefore x is equal to 2/3. Okay, so now we know what 2/3, we know that's that. So now I know that KL, which is 1 minus 3 lambda A plus B, is equal to 2/3 times Km, A plus 3 over 2B. Right, so now all I have to do is work out what my lambda is. So I've got, so if I compare my A's, let's make an equation in A, and I make an equation in B. So in A, I've got 1 minus 3 lambda is equal to minus 2/3 lambda. And then I've got, if I multiply this through by 3, I've got 3 minus 9 lambda equals minus 2 lambda. And if I add 9 lambda to both sides, I've got 3 equals 7 lambda, and therefore lambda equals 3 over 7. And if lambda equals 3 over 7, that means mu is equal to 6 over 7. But the final answer we want is the value of lambda. Okay, so not easy, not an easy question. So the key things were what? The key things were the ratio between lambda and mu, which lets us then replace all of the mu's and leave us with just one unknown. Once we've done that, it's pretty much like all the other questions. I've got one path and two paths, and then once I've done that, it's just a case of using this ratio.